All right, so we'll be looking at organic reactions. So this is 2H CH260. Okay, the content is CH260. All right. So we'll look at organic reactions and you demonstrate some examples. It's a very short lecture, and we need just to be able to understand and see, visualize the type of reaction that is taking place in each complex or structure we are given. All right. So we can start. Okay, there are basically four type of organic reactions. In fact, they are ionic reactions, but let me just say they are organic reactions. All right. So we need to be aware of these type of reactions. There are four of them. So when that, the reason why I've written ionic is because of different polarity. Where we have a positive and negative, but in covalent compounds we find same things. So that means we have non-polar molecules, and the polar molecules are these ionic compounds whereby we have the positive and the negative combining together. So in these all the reactions we'll be able to see the electrophile and the nuclear. We'll talk about those later, electrophile, nucleophile, you understand them later. So it's a series, so don't rush. Okay, so the first type of reaction we'll look at is substitution. I'll give an example and you'll be able to see in your past papers. So substitution reactions is a situation whereby, okay, let me not say anything. We have also addition. It's not additional, but addition reaction. Take me seriously. It's addition reaction, not additional reaction. There we talked about or any other lecturer will make you fail. So you write addition, not addition. The other type of reaction we have is elimination reaction, where we eliminate a certain substance. All right, so we'll look at it to give an example. The other type of reaction is rearrangement. Okay, it's a rearrangement reaction where we see molecules rearranging themselves. Let's say the molecule is changing from ketone to aldehyde, so we'll look at all those things. So I'll give an example. Basically, as I'm going further, I'll just give examples and visualize, see what is happening, then you'll be able to explain. All right. So the first reaction we are talking about is substitution reaction. So what happens in this reaction is that um, we substitute a certain molecule, then replace. It's more like it's a replacement reaction. That's what I can say. We replace something, then we remove something. Okay, so the more reactive something, it will go there and attach. There's more like displacement reaction. Okay, whereby the more reaction will go, the more reactive element will go and react to that molecule, the mother or the parent molecule. So what will happen here is, um, what is going to happen is that this thing here, we are able to see those are electrons, right? So there's more there's more electronegative element between carbon and oxygen. Oxygen is found on the periodic side of the, I mean on the light side than carbon. So that means this is more reactive. So this bond will break, and the carbon will remain with the positive, then the oxygen will remain with the negative, then with those um, um, these are electrons, so it has been charged negative. Then there are those electrons that we have there. All right, so we need one more guy to react to this. So this hydrochloric acid, I mean this hydrogen also, will come and attach there. So remember we had another hydrogen there. So the oxygen now will get, it had that hydrogen, it had two lone pair like that. Okay, plus this bond where it had gotten the negative, so the hydrogen will come sit there. So hence the formation of H2O. Then from there, the hydrochloric acid, once also this bond breaks, all right, so the bond of hydrochloric acid and hydrogen will also break. So hydrochloric acid is more reactive than hydrogen, so the hydrogen will get a partial negative, all right, positive, then the chlorine will get a partial negative, like that. We learned about this. Okay, so from there, then the positive one, is the one which came to this nucleophile, the negative charge of oxygen, so it has been attached, it's here. Then the electron, now this chlorine will come and donate to the positive. That's why they have formed a bond here with carbon. Have you seen? Alright, so that's how the substitution. So we substitute something. So this chlorine has been substituted because it's more reactive than this hydroxide. Alright, so that's how substitution reaction is formed. So you need just to visualize one thing in substitution reaction, where you see to say something has exchanged within the reaction. So if something has exchanged, Juju, so if something has exchanged within the reaction, so that means, Juju, close the door. Close the door. So that means that the reaction is actually a substitution reaction. Just look at if the things, the reactants has exchanged at some point, then you'll be able to definitely classify as substitution reaction. So that's how you can go about substitution reaction. So the other type of reaction you can talk of is addition reaction. I'm repeating this. It's addition, not additional reaction. Okay. So for this one, this is where we add something. Have you seen this double bond? Once we break this double bond, it means we break like this, we will have two pairs. So we'll form something like this once we break. So that bond and that bond, they are here now. So we can bring these two also, we can break, alright? So the moment the bond also broke, we formed some kind of positive charge partial and also negative charge partial, like that, okay? So this was formed, just that you can't see it, but that's how the reaction is formed. Always the reaction is formed from the positive and negative. That's how we neutralize things. Okay, so also from here there was some exchange of positive and negative. There's this element which is more electronegativity and also more, so that one which is more electronegativity is the one which would react this side, and that one which was an electrophile, which is lacking an electron, so it will come here. All right, so then the bromine will come there. So this then has been neutralized. So that's how we form these addition reactions. So you look at just mostly these addition reactions, they are formed as a result of molecules, especially alkene molecules like these, they which are double bonded. They have a space, they are unsaturated, so they have a space to bring these molecules to be added to them. So hence addition reaction. So whenever you see more, like especially these double bonds, when you see these double bonds, please just know that I'm likely to form addition reaction, and the molecule that you had on the other side, it combines, or it has been embedded or combined with the other molecule. Just know that that's an addition. So you should pay attention. They bring different structures, so it's up to you to visualize, is this an elimination arrangement or what. So the other thing that we talk about is about elimination reaction. So this elimination reaction is where we eliminate a certain substance, all right, I mean atom, from a compound or a molecule. So if you look at this, we'll eliminate this carbon which is here, I mean this chlorine which is there. The chlorine will react with the potassium to make what, a salt from this hydroxide. Okay, so the hydroxide now will swallow some kind of H. In short, the hydroxide will get some H from this from this isopropyl, if I'm to say an isopropyl or whatever molecule you call it. It will swallow some kind of one hydrogen, and what will be formed is this hydrogen which was here, one hydrogen will be swallowed there by the hydroxide. It will be attracted by the hydroxide. Then the potassium and chlorine, they form something. Then this bond is the bond that will form there to make a double bond, and we have seen this double bond which has been formed there. All right, so what I was trying to say is this chlorine with carbon which is here, it will remain only with the two hydrogen. Right, then this bond which was here, All right, hydrogen will give some, because of this guy which is attracting to form water, the hydroxide will eliminate one hydrogen here. Okay, it will eliminate, that's why it's called elimination reaction. It will eliminate one hydrogen there, and the space that will remain, it will actually have this double bond partially. So it will combine with this hydrogen carbon there, it will form a carbon there, then these they will remain. All right, all right, so those they will remain with that, like the way they are. Then the hydrogen which has been gotten from that, it will form some kind of H2O. Then also the chlorine and the potassium, which actually resulted in this double bond when we removed, also we eliminated this chlorine, because chlorine and potassium, group 1 and group 7 element, they like to form the same bond, so that's why it's influencing that. So it's a potassium chloride we are forming there. All right, so that's how elimination reaction is done. We eliminate some substance, some kind of substitution, but not really. Why? Because we have eliminated something from here. All right, by virtue of us removing hydrogen there, this forms an elimination reaction. Would have said substitution reaction, but substitution reaction would have been the exchange. All right, the exchange of these two substances, where this one goes there, then the other one goes there, but this is different case, so know the difference. All right, so we can now proceed with the last reaction, which is the rearrangement reaction. It's called rearrangement, not molecular arrangement. We can say molecular, but it's called rearrangement reaction. So there are times whereby ketone aldehydes, they actually exchange because of the position. So suppose we have a molecule like that, then at the end there we find that the oxygen is between the carbon. All right, that means we have what we call a ketone. But when you again the same, this oxygen can exchange. There are times whereby again this hydrogen can come a different position. All right, it can come at this point at the end there, then will form what we call an aldehyde. So we can arrange within the molecule, we can arrange certain things. So like for example, in this case here, all right, we can see this bond has been broken. All right, and it has come here. All right, that means once it has come like that, then this guy will get some partial charges. All right, the hydrogen which was between this, the hydrogen which was here, or let me say this one, then it has also exchanged to that point. So it has just rearranged within the molecule. There's nothing changing, but within the molecule we can see molecules or atoms exchanging the position. So that's what we call rearrangement reaction. You can see this hydrogen after exchanging. Okay, we can see this hydrogen after exchanging. So what we are trying to say, we are trying to stabilize this molecule by forming the double bond between carbons. So the double bond which was here, we have shifted to here, right? So this will actually let me demonstrate to say it is this hydrogen is the one which will be gotten, and it will shift to this point. All right, because there was an electron which remained, so that has been attached by that. Then that means we have rearranged the molecule. Within the molecule, there's nothing we have brought, there's nothing we have gotten, but we have just rearranged the arrangement of the double bond and also the arrangement of hydrogen. So hence that forms rearrangement rearrangement reaction. So this marks the end. So those are the things. Go check in your past papers, you'll be able to see now. I didn't want to bring examples. I'll solve in my document where get my line, you'll be able to see a lot of documents, solved documents, and we made some tutorial sheets. So this marks the end. Thank you very much.